Hello. People are trying to change what you think and how you relate to the world. They're directly trying to mess with who and how you trust. They're impacting your sense of belief. You may have already fallen victim to it and not even known. I can admit that I have. My name is Andrew Jenks, and I run the Azure Media Security team at Microsoft. I also co-head Microsoft's efforts around Media Provenance, and am the chairperson of the Coalition on Content Provenance and Authenticity. Along with my partners from across the industry, I've been working in the disinformation space for about 3 years and the media security space for about a decade. Today, I'm here to give an introductory talk on combating manipulated media, focused on media provenance. This is a broad basis for education, instead of a deep technical talk. By the end of this talk, you'll be able to answer 3 fundamental questions about synthetic media. What is synthetic media? What solutions are available to combat it? And what are organizations doing to develop technical solutions in the space? If you read the news, you've seen headlines like these. They're scary and they're real. I used to try to keep this slide updated with the most recent stories of malicious synthetic media, but in the past year, the number of stories has grown to the point where that's impossible. We're seeing synthetic media play a role in protests, coups, and disease transmission worldwide. And that makes this a critical and growing problem to solve now. But this is not a new problem. This image was one of the first widely circulated Photoshop images, and it's from 2001. Examples of synthetic photos predate even this. Falsification of media has been around almost as long as media itself. So what's changed that warrants solving this problem today? Tools have gotten easier, cheaper, and more available. They've also expanded from still images to video over the past 20 years. For example, when this image was created, a copy of Photoshop cost $20,000, required powerful hardware, and needed a hardware key in order to use it. Now, the same tooling is available for a $24 subscription a month and can be run on any tablet. Tools to create synthetic media are widely available to the average consumer. The democratization of tooling brings with it a new group of devious actors. Deepfakes get all of the headlines, but it's important to realize that not only is synthetic media not just deepfakes, it can also have positive impacts on people's lives. For example, we can add captions for the hearing impaired to a video using synthetic media. We can have fun with apps like Wombo that generate synthetic media of our friends. Just because it's synthetic doesn't mean that it's bad. But some is. Malicious synthetic media is any content that's built with the intent to harm. This can include trivial changes to media. Deepfakes are a subcategory of malicious synthetic media. They use more involved AI and ML techniques to generate better images, but all forms of malicious synthetic media can be problematic. When you think about the problem space then, remember that malicious synthetic media includes not just deepfakes, but also cheapfakes and content reuse. The Nancy Pelosi video on your screen is an example of a malicious synthetic video where the original video was just slowed down slightly to make it appear that the Speaker of the House was intoxicated. It's what we call a cheapfake, a trivial manipulation. The Mark Zuckerberg video in the middle of the slide is an example of a true deepfake. His lips were edited and replaced, and a new audio track was inserted to make him say outlandish things. When this video was released, it had a material impact on Facebook's stock price. A related problem is media misuse. Individuals or groups simply reuse previously published images, but in different contexts, to try and convince the viewer that the photograph provides evidence supporting some invalid or malicious claim. In this real example, the same image was attributed to 5 different locations, none of which were accurate. My personal favorite is that this picture of a fire purports to show the Arctic burning. Authenticating trusted sources used to be easy. Nobody faked the New York Times that was delivered to your doorstep or television broadcasts because it was hard. But when you went direct to the BBC's site over SSL, you could be pretty sure that the content that you were viewing was what they had actually published. So why is this a problem now? It's really about scale and accessibility. First, the ability to make fake media has become significantly easier. And second, users can distribute malicious synthetic media faster and more broadly than ever before. By the way, you as an end user can go back to these same methods today to get a better idea of trusted sources. When you see something unbelievable, it takes only a few minutes to check it with a trusted source, like one of these. But nobody does that. Today, people get their news from YouTube, Twitter, Facebook, and other popular social networks. Sites like these have become the dominant news outlet of the day. In one BBC study, 10 times as many people viewed a story on Facebook as the original story on the BBC site. And that's just one story on one social network. Once content completes this double hop and begins getting reposted, you lose any sort of link with the original. You can't know that what you're looking at is the same as what was originally published. There's just no real way to tell. And note that I'm not blaming social networks here. The same problem exists anywhere media is republished, for which there are many routes. This is a question of scale, and scale in the internet age is a universal problem. So we leave the problem of detecting fake images and videos on social networks and other outlets to end users. And they're terrible at it. Like, they're really terrible. The majority of people don't trust in their own ability to tell if a piece of news is real or fake. This stat is getting worse, even as the amount of news being consumed from social networks is increasing. Today, only 35% of people trust the general news and information content they see. We also have a time problem to deal with. News is temporary. A story is only in the public view for about 72 hours before it's replaced with new news. That means you only have a few hours to impact false reporting before the damage is done. And people watching videos on social networks tend to watch less of the content than in other outlets, potentially ignoring important clues that media might be falsified. All of this adds up to a big problem. For you, for society, for businesses, for democratic processes, and for journalism. Real harms are being done. People are losing faith in previously trusted sources. They're losing faith in leaders. They're being directly exploited in media. And in some cases, that's based on manipulated media. But it gets even worse. It turns out when there's a certain amount of disinformation in the world, people begin to believe less of the true information. It's called the liar's dividend, and it's a fascinating topic in its own regard. But what it comes down to is that when anything can be a fake, and you can't tell the difference, you can't be sure of what's real and what's not. This directly harms your relationship with reality. All of this is a form of what we call cognitive hacking, changing what people believe, even when those people are trying very hard to make very rational trust decisions. So the problem is scary. What can we do about it? Well, we can actually do lots of stuff. We can make people smarter about the media they consume. Before sharing a story on social media, ask yourself, where did it come from? How do I know that? Verify your sources. We can institute new policies on platforms to help protect users, and many of the social networks have been doing this to do just that. We can pass laws. We can talk to our legislators about the problem of misinformation in the online environment. But we can also develop and deploy technical solutions, and that's where we'll be focused for the rest of today. When we think about technical solutions for malicious synthetic media, there are really three areas we worry about. Detection is the ability to automatically tell if a piece of media is fake. Authentication is the ability to tell if something came from a trusted source. And provenance is the ability to get additional information about a piece of media that helps you as a consumer make a more educated decision about whether or not to trust it. Everyone jumps to detection as the first solution because it sounds great. Just build me technology that tells me when I'm being lied to. Tell me when I see a piece of malicious synthetic media. And this is a very active area of research. There are lots of techniques that have been developed in just the past few years to try and tell when an image or video has been manipulated. Major technology companies, including Facebook, are leading the charge on the development of new techniques to detect synthetic media. Because of this support, promising developments are constantly being made. The problem with detection is that it's also an arms race. If you have a good detector and you attach it to a malicious synthetic media generator, you can train your generator to make malicious synthetic video that can't be detected with your detector. And today, the best AI detectors are only 60 to 75% capable. That means they misidentify a quarter of information, and that success rate isn't rapidly changing. And if you misidentify media, you're back to that liar's dividend, where you can't be sure. Both false negatives and false positives end up hurting the end user's ability to trust media. Claiming something true is false is just as damaging as claiming something false is true. Therefore, we believe that while detection is a useful and necessary tool, it does not fully solve the problem of malicious synthetic media in the environment. Media provenance is another technique that can be utilized, and it provides additional information about a piece of media that you're consuming. That information, those pieces of data, can be anything you want, from the title of a work to the full list of edits performed on an image. That data is bound to the actual piece of media you're describing. It can also be authenticated by a signature so you know who added it. There can be multiple pieces of provenance in a single piece of media. And if desired, these can be linked together to provide a chain of trust all the way back to the origin, the original camera that took the image. Provenance is entirely additive and optional. This doesn't require new media formats, and it works in the clear media space. This doesn't replace the role of clear media, and it doesn't replace the role of anonymity on the web. It simply provides a new ability to help end users evaluate the media they see, if it's present. Provenance data comes in with metadata in something we call a manifest. There may be one or more manifests for a given piece of media. You can think of each manifest as representing a step in the process of producing and delivering an asset to a consumer. That manifest is cryptographically bound to the media asset through hashing of the actual media content. This is a way of tying the digital content to the provenance data, so a bad actor can't alter the content without breaking that provenance data. The manifest is also signed by the manifest creator. This provides a mechanism of tying actions back to a publisher in the production process. When you validate a provenance manifest, you can be sure that the information in the manifest is what the publisher put there, and that the actual asset hasn't been edited on its way to your eyes. A manifest has 4 parts. First, it has those fingerprints for the asset itself. It also has metadata. If we were creating a manifest for the recording of this session, for example, it might contain the session title, my name, and the delivery date, but you can put whatever information is important for your specific scenario in there. It can, but doesn't have to, contain edits you made to a file. So if you started with an original image and photoshopped it, and you want to include that information so that people get traceability of your image, you can include those edits to provide that. And finally, it contains a digital signature over the data above to link it back to a certificate that shows a particular certificate holder is vouching for that stuff. Signatures are cryptographic constructs where a secret only the signer knows is used to make a value that anyone can verify came from that signer. This means that consumers can be sure that the claim came from the signer that produced it. So what's important here? This system is as strong as well-known cryptographic processes. An end user or user agent can validate the video at consumption time to make sure it's unchanged since publication. It can be bound directly to common media formats, including those on this slide and many more. This, we believe, is generally applicable. It works in the clear media space, so it doesn't break any infrastructure that exists today. This is purely additive, not a new media format. Media provenance is an area of active research and development. Let's talk a little bit about where solutions for media provenance are being developed today. There are three main bodies that are leading the charge on media provenance. They are Project Origin, the Content Authenticity Initiative, and the Coalition for Content Provenance and Authenticity. Project Origin was formed based on a high-level conversation amongst BBC, the New York Times, CBC, and Microsoft. It was started to try and find technical solutions to the rise of deepfakes in media. It was specifically focused on media manipulations from the point of production, the time a news media site released a story, to the point of consumption, when an end user consumed that story, taking into account that double hop we talked about. At the same time they were working on that technical problem, the Adobe-led Content Authenticity Initiative was investigating the same problem for still images, from the point of capture, the point of taking an image on a camera, kind of to the point of production. It was the same problem in a slightly different problem space. So these two problem spaces together covered scenarios related to provenance in media all the way from the point of capture through editing to production to the end user, and across both still images and videos. These groups got together and decided there were probably a lot more uses for content provenance generally. And critically, they decided to prioritize a single interoperable solution for standards instead of developing similar answers twice. That solution is being built in C2PA, which is where that interoperable standards work on provenance and authenticity is being done today. This slide shows how the organizations relate to each other and the wider industry. CAI and Origin are working with a large number of other companies, individuals, academic researchers, and others to gather requirements from their partners and providing those to C2PA as requirements and workflows. C2PA is then turning that information into technical standards that can be implemented. They're publishing those specifications publicly and using CAI and Origin to scale uptake and provide best practices and reference implementations. Finally, organizations like news providers, cloud providers, and social networks can use tools that support provenance to publish media to end users who will be able to know where it came from and get additional information about the media. Like I said, C2PA was developed to create technical specifications and standards. But what that really means is that it's creating the base layer for provenance solutions to make sure the various ecosystem players play well together. C2PA is a very transparent organization. It publishes its charter and guiding principles publicly, which you can find on the website. And in September, C2PA published a draft specification for public comment. They encourage public review and feedback to build the highest quality spec possible. More information, including the full specification, is available at the website listed here. Enabling media provenance is an ecosystem-wide problem, and it requires an ecosystem-wide solution. To enable that, C2PA is made up of a broad range of collaboration partners. Members include news media organizations, technology providers, cloud service providers, and social networks. Other notable members include Witness, a nonprofit focused on citizen journalism. They're particularly worried about issues of anonymity and privacy for individuals, and have helped the entire organization ensure that those concepts are baked into the specs and standards from the ground up. C2PA is really the epicenter of provenance and authenticity work today, and the close collaboration amongst peer companies gives me great hope that we can change media consumption for the better. Here's what I want you to take away from today. Synthetic media is a large and growing problem, and it's getting worse as time goes on. What got us here in terms of authenticating trusted sources won't get us through the future. We need new tools and new ways of thinking. Various bodies have worked together on an interoperable approach to provenance. That solution is being standardized in C2PA today. And the application of provenance across scenarios is extremely broad. Trust is a universal need, and we are investing in a universal technical solution. Thank you.
And we're back, and I'm joined now with Andrew, the presenter from this past talk. Hey, Andrew, nice to meet you.
Hi, Darsh. Thanks so much for having me here today.
Absolutely. What a cool talk. I mean, something I haven't really thought too much about, probably the thing that I'm the least familiar with of the things that we've talked about today so far, especially the part where you're talking about the rise of adversarial networks and how you kind of are playing this cat and mouse game is just fascinating stuff. So thanks again.
Yeah, thank you.
So starting off with the first audience question here from Tim, we have a pretty good question. So what do we need to do to help users themselves understand that the content has been origin authenticated when they're viewing it? For example, I think he refers to the HTTPS lock icon that's pretty familiar to most people at the top of the browser by the URL. So what similar things we need to do as an industry to help users understand the similar security for the content?
Well, that's actually a great point of comparison, right? When the HTTPS lock icon came out, nobody understood what it was and what it meant. And we had to go through this very long process of user education. And now most people understand roughly what that means, right? For C2PA content and for content with provenance, we're going to have to do a similar type of activity where we educate users on what to look for and what that means and the promises that we're making. So C2PA is producing UX guidelines that we're recommending the industry use that includes a specific icon for this. And our goal is to drive uptake of that icon consistently across the ecosystem so that people understand from site to site or app to app that when they're viewing content with provenance, they can get more information from this particular icon and this particular thing. But we know that's going to be a long process, and we're gearing ourselves up for that. And educating consumers is always a difficult thing to do. So we're ready and to rise to that challenge.
Yeah, it makes sense. I think the great point by the question asker making that comparison, I think. Yeah, so the next one here is, can we move fake detection itself to the edge to better support scale?
We think so. And we think that that problem actually becomes easier as we start to see lower cost silicon that implements ML and AI processing units or neural processing units. We think as that silicon develops and as the price point for that drops, edge availability of fake detection becomes a little bit more viable. Right now it's expensive and it's a little bit slow and we're not there yet, but based upon what we see in the market today, it looks like we're headed in that direction.
Got it. Got it. And the last question I have here so far is what strides are being made to do this detection and authentication in near real time for low latency streams?
Yeah, that's key. And that also enables things like provenance for live streams, right? Which is a very interesting area. We're working on that problem now. I will say that validating provenance itself is really a fairly quick and easy process and can be done in a low latency environment. That's not always true of detection. In some cases it is, but we're just not as fast at detection as we are at authentication and provenance today, because that's a signature check and some minimal validation. And that's much, much quicker than some of the detection operations that we do. So when I think about low latency environments, we really think of provenance as the preferable solution there, just because it is so much faster and it was designed to be very, very quick.
That makes total sense. Yeah. All right. I don't think we have any more audience questions coming in, or I haven't seen any myself. So Andrew, thanks again. Do you have any last call to action or last notes for the viewers at home?
I just look forward to looking back on this problem in 10 years and saying, remember when we were all so concerned about deepfakes and cheapfakes and malicious synthetic media, and look at the strides that we've been able to make and really help society deal with what is a large and growing problem through the various organizations and technology partners that we have. So thank you very much for having me here today. It was a pleasure getting to join the conference. And I hope I've given folks something to think about.
I certainly have something to think about after that. Thanks so much again. A very important topic. Up next, I'd like to introduce our last speaker for the day. Yep, that's right. Day one's already coming to a close, which is Vineeth, coming from the company StatSig to talk about experimentation in video services.